This is for Year 12 Methods that comes out of Heffernan 2020 Exam 2, question number 5. So part of the graph of this has been drawn. Just double check that everything that we expect there to be is correct. +1, XC, and I open up that graph and I drag and drop. And yep, that's about right. Happy about that. Okay, so that's Y. And that's the graph of Y. This is now F, and F's got a restricted domain from A to infinity, and it's the same rule as that, where A is the least value for F to have an inverse function. So it has to be 1-to-1, so it's got to stop there, which means I can get rid of this bit over here, and now I've drawn F of X. Whoa, undo that. That's F of X. So A has to equal 0. Find the rule of the inverse of F. So it's no longer, that's what A is, A equals 0. So we're now looking for this. So the domain of F is 0 to infinity, square bracket. The range of F is 0 because it's an asymptote up to y-intercept 1. And it's a square bracket on the 1. So when I'm working out the rule and the domain of the inverse will be the range of the original 0 to 1. And instead, so x will equal 1 on y squared plus 1. And solve for y. Now, do I want the positive or do I want the negative square root? How can I tell? This is going to tell me what I want. And I don't want the negative square root because that's going to be a negative answer. Its range will be this, and the range has to be positive. So the range of the inverse will be the domain of the original, and that's got to be positive. So I want the positive square root. So I want f dash negative 1 of x will equal the square root of negative x minus 1 on x, or you can have any other variation of that as you like. You can write that, you can simplify the answer and have it as 1 on x minus 1, doesn't matter. Find this, so now I'm going to grab this, I'm now going to grab this and sketch it as well. And grab my original. So the area bound in square units, so if I'm looking for the intersection, it's going to be 0.6823. So now I've got this other curve that looks like that, and I'm now looking for this area in here, and that intersection point is 0.68. So I need one definite integral where I have this as my top, my curve, and another one where I have the inverse. So find the area in square units, 2 marks. So 1 mark will be the definite integral, which we go from 0 to 0.682327, and that's going to be f of x dx plus the integral from 0.682327 up to that intersection point, which will be 1, because we said the domain went up to 1. And that will be the inverse of x dx. And since my answers are correct to 4 decimal places, I can do that on here quite comfortably. And I can go analysis, gsolve integral. If I take that one, so I go XE 0.682327 to 1. That's that area there, and I grab it. And then I do the second one, which will be analysis, G-solve integral cancel, 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 cancel. Much better. Okay, analysis, G-solve integral. And this time I want that curve, XC, from 0 to 0.682327. And I pick that area up, plus execute, and I'm looking for 0.1. This is the 133,196 plus 0.598766, and the equal 0.73196 to 4 decimal places, 0.7320 as being the area to 4 decimal. Really important, if you want to round to 4 decimal places, put this to many, many decimal places, and that's easy on your calculator. Okay, what's next in this question? The graph of f. Now remember, f equals 1 on top of x squared plus 1. And I've got to show that it equals this when these dilations occur. Okay, so if you dilate by a factor of 3 from the x, you replace y with y on 3. So y on 3 equals 1 on x squared plus 1. So y equals 3 on top of x squared plus 1. Dilate by a half from the y-axis, then you replace x with 2x. So y equals 3 on top of 2x squared plus 1. 3 on top of 4x squared plus 1. And you reflect over the y-axis. You replace x with minus x, which is 3 on top of 4 times minus x squared plus 1, which equals 3 on top of 4x squared plus 1, and that's what we've shown it to be. The domain of h, well, the domain of f was 0 to infinity. And we wrote that from right up here because f was involving a. So if that's what f is, if you dilate by a factor of 3 from the x-axis, that's a stretch up or down. That doesn't change the domain. You dilate by a factor of a half from the y-axis, you would halve it, but it's still going to be the same, because if you go from 0 to infinity and you halve it, it's still going to go to infinity, because you can't halve infinity. Then you reflect over the y-axis, it's going to be on the other side, so minus infinity to 0. So the graph, instead of looking like that, is now over here. So let's graph H and its inverse. Okay, so we're going to be at 3, and we're going to look something like this, with an asymptote at y equals 0. That's going to be h of x. If I now consider its inverse, it's going to start here. It's going to be an asymptote at x equals 0. It's going to look like this. So there's the graphs of h and its inverse, h of x. And using the fact that the inverse equals x, so 3 on top of 4x squared plus 1 equals x, find a rule for that. Okay, so that's what h of x is. So I've actually got, h, and I've got this where x appears. So instead of 4x squared, I've got 4 inverse of h of x equals x. So I've got to rearrange that by itself. So 3 over x equals 4, h of inverse squared plus 1, 3 on x minus 1 equals 4 lots of h inverse of x squared. H of inverse of x squared will equal 3 minus x on 4x, and the inverse of x is going to be plus or minus the square root of 3 minus x on 4x. And by looking at the graph, I know that I want the negative square root because we're down here. So it's going to equal minus, the 4 can come out a half, the square root of 3 minus x on x. And that's going to be my rule. And then lastly, given that this is bigger than this, find all the values of k. So let's have a little look at that. That is from negative 1 to 0. That's that area there. And that's going to be the integral from k to 3 of the inverse but negative. So notice that the symmetry is going to happen in this question again. Those areas are equal to each other. Of k, and this depth will be the inverse of h of x of k, and this bit here is this area here, which goes from k to 3 just of the inverse. So this point here is this point here. If I put negative 1 into 3 over 4 times negative 1 squared plus 1, 3 on top of 4 plus 1, 3 on top of 5, or 0.6, then that point there is negative 1 and 0.6, which means k has to be 0.6.